Hello everyone and welcome to the next section, which is our Android architecture components. Excuse me. And this is quite an important section in that it kind of underpins the design of the rest of our donation app. So we're going to change drastically how we design our app and bring in these new Android architecture components. So the way I've structured is that we have one section on architectural design patterns. So you may be familiar with some of this. We'll talk about kind of design patterns in general, a bit of history, a bit of background, where they came from, just to kind of refresh your memory. A quick look at our MVC, MVP, and then MVVM, just from a kind of quite a high level perspective, and then maybe drill down a little bit into how it applies to Android. We'll then look at the architecture components, which are specific components within the Android framework to allow us to just implement better design, basically. We'll then look at the MVVM pattern in Android. So we look at that model, view model, specifically how it applies to Android, and then how it applies to kind of a simple example, and bringing in those and utilizing those architecture components, okay? And then finally we have a section there on our code walkthrough. So we look at how it applies and how we have applied the MVVM pattern within donation, okay? And then there's a lab there that will take you through kind of a refactor of the current version of donation and bring in then our again, I'll use the terms now, the view models. We'll be working with live data. So under the hood it'll change quite a lot, but from a user's perspective they really won't see any changes. But it's really from the developer's point of view that this whole section is quite important, as going forward every other version of donation that we build will be applying these the MVVM pattern. Okay, so I'll hand you over now to the next section, which is our Android, or the architecture design patterns. Okay. Bye-bye. Hello everyone and welcome to today's section, which is our architectural design patterns in Android. So this is kind of a first look now at we're going to kind of restructure and refactor our donation app and bring in some of these kind of new design patterns. The one we're going to look at is MVVM, which I'll cover in more detail later on. But in this section I just wanted talk about kind of design patterns in general, and specifically then the architectural design patterns, which is kind of a more recent addition. Okay, so the way I've broken it down is as follows. Start off with a quick introduction. So again, just trying to put things in context for you about why design patterns are so useful and so important within the development world. We'll look at an overview and some benefits of using design patterns. We'll then take a high level-ish view look at MVC, MVP, and MVVM. Okay, so model view controller, model view presenter, and then model view model, and then just a conclusion, just to kind of wrap up the section. Okay, so just to begin with, just to kind of, as I said, put things in context. Okay, so mobile development has changed greatly in terms of not only what is capable on a device, but also in terms of what users want and expect out of the average app. So look, it's only been around since 2007. That's when the first Android app was released, okay? Or Android device, and obviously apps come with that. But if you look at what your phone can do now, and what the new additions over the last couple of years, especially, I guess, they've changed a huge amount. Okay, so what's capable on a device has massively changed, right? So with that, developers have had to change how they build things in order to account for more complex, robust apps, and it's all tied to scalability. Okay, so like as the apps and the frameworks bring in more features, it gets more complex, it just gets harder to manage. Okay, so again, that's what we're trying to kind of highlight here, that you can't just dive straight in and just start coding if it's going to be quite a complex app, right? And again, just if you want it to be robust, if you want it to be scalable, you want it to kind of stand the test of time, there's a bit of thought has to go into it. Okay. So the Android development community in particular has had a huge shift in focus from massive logic heavy activities to MV whatever based approaches to help split up the logic. So again, especially working in teams, right, it's all about kind of trying to split up into smaller components and less coupled, so decoupling those components moving away from those logic heavy activities. Okay, and again, we'll kind of refer to that now when we look at the different patterns. Okay, a little bit more on the introduction there. So with the adoption of Kotlin and the introduction of architecture components, so again, we're going to look at those in the next section, but these are kind of a recent addition to the Android framework to just help improve design, basically, okay, within an Android app. So it's now much easier to get off the right foot with new Android apps to help ensure their maintainability and scalability for the future. Excuse me. However, as those apps have had time to grow and mature in the wild, it is often necessary to employ other design patterns to allow apps to grow without becoming unmaintainable. So again, I think I'll talk about it later on, but initially MVC was kind of the chosen approach, but that was okay when the features that you could implement in an app were pretty straightforward. They weren't too complex. But as you see yourself with the devices and your kind of retina scanners and all the kind of sensors and locations, and there's so much more you can do with an app now. To try and manage all that with MVC has kind of gotten a bit out of hand. So that's why as time went by, developers had to try and apply other types of design patterns, and we will discuss 3 of the most common Android architectural patterns: MVC, MVP, MVVM. Their main purpose of producing scalable, maintainable and testable code, and that's a big one recently as well. Just being able to test your code. Initially there was very little testing done, but as apps got more complex, testing became more and more important, because you can't leave an app out there and then within a couple of weeks there's bugging, there's bugs in it, there's crashing. So to make things easier to test, it can be driven by the type of design pattern that you want to apply as well. Okay. So to look at some of the benefits, again, kind of an overview as well, okay? So what are design patterns and why are they useful? So design patterns represent reusable architectural building blocks within a program. Good building blocks in your code will lead to clean code, resolve common problems using common paradigms, making it easier for multiple developers to work on the same project, be robust and well tested, and be easier to understand and maintain. So with design patterns, developers can apply known solutions to existing problems. So again, design patterns, they've been around a while, and they're a kind of a tried and tested way to build Android applications, okay, and any application for that matter, right? It just happens that obviously we're talking about mobile at the moment, Android, but design patterns can be applied in any context, okay. The concept of design patterns appeared in a famous book by the same name, so the Gang of Four, right, which described 3 categories for these patterns. So again, it kind of even goes back to engineering, and that's kind of where it came from originally. And then it ended up, again, I'll talk about it a little bit later on, ended up kind of coming into the web world, and is now leaked into every other facet of development and types of different development applications that can be built. Okay, so there's kind of 3 main categories that initially were there, right? You had your creational, so it delivers solutions for creating classes, objects. Some of those mentioned there would be, you might be familiar with, the singleton factory builder patterns. We have a structural category, which are about arrangement of classes and objects. So your composite facade adapter, and in behavior, gives you ways to communicate between those objects and classes. So again, specific ones there will be command, observer, and strategy. Okay, to look at it just in a kind of a more complete list of the 3 different categories. You may be familiar with some of them, you may not. If you want, you can go off and kind of investigate those in more detail. I'm not going to do that today. Okay, just going to focus on the ones that are applicable to us. Okay, but more recently, there's been a 4th category has come on the scene, right? These architectural design patterns, which helps developers follow an architectural style. They help you separate different components within a project. So again, as our apps get more and more complex, there's more and more cogs in the wheel, so to speak. There's more and more components that are coming together to work together to build that particular app. Okay, so in the enterprise world, one of the most popular design patterns is the 3-tier or 3 layers pattern, right? Another useful one is the client server model, and then mobile apps also benefit from many of these patterns, but some work better than others. So that's what we're going to look at now. We're going to look at 3 of the most common architectural design patterns that work for mobile apps, and kind of little compare and contrast, and try and impose upon you why, at the moment anyway, MVVM would be the better approach. Okay. So to look at, as I say, common architectural design patterns within Android. But look, a lot of these are applicable in the web world, desktop, most basically development type applications. Okay, so the model view controller, or MVC, and your model view presenter, MVP, are 2 design patterns that are very similar and have much in common with MVVM, but there are subtle differences, and that's why we're going to be using and applying the MVVM pattern. Okay, now, just as an FYI, I think I mentioned this already, Google didn't push for one single design pattern for Android in the beginning. However, the documentation used MVC more often than not. And as I say, at the time, because Android was only kind of in its infancy, the features and the library itself wasn't that rich in terms of what you could do with the mobile app. So the MVC approach was perfectly fine at that particular time. Okay, but as we'll see, when compared to the other patterns, and when Android apps started getting more complex, MVC wasn't really the best approach. Okay, so now this pattern has 3 components. Again, the model view controller. Hopefully you're familiar with some of this, but we'll just briefly describe it again. Oh, sorry. So an MVC, communication between components, looks like a triangle. And again, I'll show you now in a little diagram next. In general terms, the view displays the state of the model, the controller handles the view input, and the model stores the result that comes out of the controller. So in the Android world, the model, if we work kind of ground up, would have been your the data, would have represented the data you're trying to show, which then would have been displayed in the view. The controller manages that, handles that view input, and in the Android world, the controller would have been your activities, which unfortunately leaked into the view as well with your layouts. Okay, so as I say, initially that was fine, but as things got more complicated, that merging of components really wasn't made it difficult to scale, and as previously mentioned, you ended up with these very logic heavy activities, which is hard to manage essentially. Okay, so to look at it in a diagram perspective, just a nice graphic, we have our, just highlighted for you there. So here's our model, our view, and our controller, and the user interacts with the view. The model will send updates to the view, and the view then sends events to the controller. So that's like, say the user might be looking at a view, a screen, a layout. They click on a button, that's an event. It's sent to the controller. Maybe it could be you want to list some data, so the controller then manipulates the model, goes off and gets your list of data, and then sends it back to the view. Very straightforward, easy to understand, easy to get your head around, and easy enough to implement as well once your app wasn't that complicated. Okay, it's just the problem started arising when apps started getting a little bit more complex. Okay, now a little bit more about MVC. It can be hard to test because of this communication model. Navigating the code can also be tedious, so the business logic should be split between the controller and the model, but sometimes the logic leaks into the view. Okay, this creates a kind of coupling that has a spiral effect. So in the end, it encourages Android developers to put the bulk of the code in an activity or a fragment, again, which gets totally out of hand, right? And this makes the app hard to maintain and nearly impossible to test. So it ended up that the MVC ended up getting called the massive view controller as a kind of a nickname, because obviously same initials, but it just got very, very out of hand, and your activities were getting far too big. Okay, despite this, the pattern is still good enough, as I say, for small projects, but there are better patterns available, and that's what we're going to look at. Okay, You may not have heard of MVP, but again, we'll discuss it here in a little bit of detail. So the MVP, or model view presenter, shifts the controller in MVC between the model and the view, naming it presenter. So there's a slight little bit of decoupling there. Okay. It helps concentrate the business logic in the presenter. So the less logic that you have in your view, or from an Android perspective, in the activity, the better. Okay. On the flip side, the presenter is also responsible for adapting the data in the model for displaying in the view. Okay, sometimes then it's kind of called a supervising controller, because it's a kind of managing and adapting that data. Okay, so the difference between MVC and MVP, it's not huge, but decoupling the model from the view has advantages. And now this is all leading up towards the MVVM, and this is where those architectural components, our view model, our live data were kind of born out of. Okay, so it's useful and it's good to understand the kind of the principles behind these design patterns initially, because it all kind of built up towards this the MVVM. Okay, final point there, it allows for more flexibility and offers easier UI and unit testing. Okay, so to look at the our MVC, so there's our MVC again, right? But if we compare it to our MVP, you can see it there. So there's a total shift there now. You can see it. The model is not dealing with the view at all. Okay, so here's our model and the view, and that's always a good thing, because if something as simple as the user rotating the screen, if that is dealing directly with the model, you could have memory leaks, you could lose data. So these are all, there's some of the common issues tied to that original MVC. Okay, but you can see here now, if the model dealing exclusively with the presenter, or as we call it sometimes, that supervising controller. So as before, views, if we have the view, your layout could be a screen with a few buttons on it. User clicks on the view, event, that's an event sent to the presenter. As before, manipulates the model, but this time the model goes back to and reads from the presenter. Okay, and the presenter will send then any updates back to the view. So this decoupling of the model and the view is it's subtle, but it's very important. Okay, now to talk a little bit about MVVM, which is the model view model. Okay, so this is currently one of the most loved patterns out there. As it has had plenty of time to mature. Again, it's been around a long time, adopted by the web community there and within Microsoft there, formalized it back in 2005, and it has eventually made its way into every UI-based framework. So again, the fact that the UI-based framework is very, very important, because it's all about that decoupling of your data and working with data and retrieving data, updating data, and separating that and decoupling that from how it's presented. Okay, so one of the key advantages of MVVM is that it offers the right amount of decoupling. Another is that the learning curve is similar to the other patterns. So if you have a good understanding of MVC or MVP, getting your head around MVVM isn't that big a jump. Okay. Just to talk about it in a bit more detail now, has three components: the model view and the view model. And again, this will map directly to those architecture components that Google now have in the SDK, right? The MVVM itself includes a fourth component, right? Even though it's not mentioned in the title itself, fourth component, which is a binder. And again, we look at that now in the next slide. And again, within the Android world, applying our MVVM approach will also involve some kind of data binding, and there's data binding libraries there for us within Android to make that happen also. And again, we look at that later on. Okay, so if we look at the MVVM, quite different to the original, but not hugely different. So again, here we have our model. The key here, again, look, model, no direct contact or talking interaction with the view at all. So again, view deals with the user, will be kind of, again, we use the same example, clicking on a button on a list, sends events to the binder, and it's the binder then will pass on that to the view model, which in turn will send it back to the binder, which it then passes back to the view. And the view model deals exclusively with this view model. So our model is kind of like our raw data. Okay, so from the Android perspective, the model could be a flat file, could be a database, local database connection, could be a cloud connection, could be an API, but that is all done and manipulated through the view model. Okay, so again, there's a quite nice decoupling. There's a nice balance of decoupling between the major components. So there's not too much interaction between more than two components, if that makes sense. Okay. So just to talk a little bit more about MVVM. So compared to MVP, and MVVM decouples the view from the view model by using the binder. So again, very important. Okay. Now, as I say, the binder is usually handled by can be a different platform or a third-party library, so that the developer doesn't have to write it. So that's going to be what we deal with within Android. The library itself has its own data binding mechanism. So what we need to do is bring in the dependency and then just go and use it. We don't have to write from the ground up the code to make that happen. Okay. The view model doesn't know about the view, or views subscribe for changes. So again, nice bit of decoupling there. So we can the view model. When the view, if the view changes, doesn't affect the view model, doesn't affect the underlying data. Again, back in the MVC world, that would have been a big issue where, as I say, there could have been memory leaks, there could have been crashes, data getting lost. So all that has been done away with within this MVVM design pattern. Okay. Now the binder itself delivers the changes from the view model to the view. This allows developing and testing the view in isolation without breaking the view model. Again, because the components are all nice and separated, nice and decoupled, you can test independently. Okay, which would have been a lot harder back in MVC, and even with MVP a little bit as well. Okay. Now, just on a kind of counter argument, MVVM isn't perfect either, but it is very good, especially in the Android development. And as I say, we will look at this pattern in more detail in later sections. Okay, so if we just compare all our graphics together, the different design patterns. So there's the original model view controller, again, like that kind of triangle, but there's our model talking directly to the view, which is really not ideal as applications get more and more complex. Okay, our MVP tries to shift that. We bring in our presenter, our supervising controller, so we decouple the model with the view, but the view is still talking directly to that kind of controller. Okay, whereas MVVM brings in this binder, and all that is concerned about is handling events and updating, right? Technically not concerned directly with the data itself. That gets its updates from the view model, which in turn gets its information from the model. So as I say, there's a nice balance of decoupling there. Okay, it helps testing. Okay, so quick conclusion there. Design patterns are incredibly useful, no matter which language or platform you develop for. Every developer should know how to implement them, and most importantly, when to apply them. So there's, as you saw there in the different kind of creational structure, behavioral, there's a huge amount of design patterns that can be applied. So a big part of development and the kind of the skill level of the developer is knowing what pattern to apply at a particular when it's needed, when it's required, right? If you don't choose the right architecture for your project, you will have a hard time maintaining it as your code base grows and your team expands. At the moment, MVVM is currently industry standard recognized software architectural design pattern that overcomes the drawbacks of MVP and MVC. Okay, but it is generally applied to more complex type of applications. Okay, so just to wrap it up there, before rushing off and trying to implement these patterns on your app as soon as you can, right? It's worth noting that although these are good principles to abide by, using all or even some of them when they aren't really necessary can lead to overly convoluted code that ends up being harder to understand than it actually needs to be. So not every app needs to implement them, but the key is to know when it's time to start. So if you're building a quite straightforward, simple app, local data, maybe just listing some information, maybe even just read-only type data, that is, it's just retrieving information and then just displaying it back for informational purposes. You don't need to go mad with all these really complex kind of design patterns, okay? And there's dozens there that you could pick from. If it's a simple app, keep it simple. That's another kind of rule of thumb within the development world. You don't need to make it more complex than it needs to be. And as you will see when we work through the rest of the material and working into our donation application, it does become quite complex, but because we want to bring in more and more features, okay? So as the features grow, it makes sense to apply a design pattern to allow us to scale up. And hopefully you will see that because we have used and are utilizing this MVVM design pattern, it will make adding new features a lot more straightforward and a lot less code necessary, okay? So other than that, just some references for you there. Thanks for listening, and goodbye everyone, and welcome to the next topic I want to look at within the overall section excuse me, which is Android architecture components. Okay, so again, the agenda, the way I'll break it down is as follows. We'll have a quick introduction, again, just put things in context for you. We'll have a general overview of the architecture components, and then I will briefly look at each component individually, okay? And then we'll just have a kind of a quick conclusion again, okay? So just to again put things in context for you. So in the beginning, Google weren't recommending any particular design pattern and approach to mobile app development, so it was difficult dealing with certain common use cases. So again, they weren't pushing any particular design pattern like the ones we would have looked at the previous section, but more often than not, it ended up applying the MVC, or the model view controller, mainly because there were simple enough apps that were getting developed at the time. Okay, but as applications got more complex, they still didn't push a particular design pattern to focus on. So as I say, it was difficult dealing with certain common use cases. Something like your configuration changes and even rotating a screen would actually restart your whole app. Okay, so you as a developer had to be able to deal with that, and that was quite tricky within the MVC world. If you didn't, if your app wasn't written very well, you would end up, your app could crash on something as simple as a screen rotation. Another issue there, sharing app state data between fragments and activities was also tricky. So again, working with the life cycle, trying to keep data in sync, and again, if as you know yourselves, each activity could be going through its own separate life cycle, and if you want to share that app data between those fragments and activities, all that was hard to manage. Okay. Now, while these difficulties are not insurmountable, the fact that they cropped up in so many common scenarios had a negative impact on the developer experience in Android. Okay, so ultimately, the developers got it done. They made sure that when we did rotate the screen, there was fixes there. There was ways to make sure that the apps didn't crash, but it was all extra overhead on the developers. Okay, and again, they just kept kind of crying out to make things easier. And getting on to Google about it. Okay, now because of all that, right, at Google I/O 2017, Architecture Components version 1 was launched, and it was a big deal back then because it was the first time in over a decade that Google officially came out and said this is how you should build an Android app. So for launched in 07, so for 10 years, even though Google kept changing and adding to the framework itself, adding to the libraries, bringing in all these new features, they never really said, look, with these new components now, this is probably the way you should build an app because this is the way they're all supposed to work together. They didn't do any of that. So when they decided to nail it down essentially and say using these particular components, this is how you should build an Android app, right? So that's why it was actually quite a big deal in the developer world, okay? So Google started to shift its philosophy by providing architectural solutions for common problems that every Android developer faces at some point. So all these common problems that would be cropping up as the applications got more and more complex, Google tried to provide solutions for that. Okay. Now, these solutions made up the first release of the Android architecture components, which were a set of libraries guided by the separations of concerns principle, making apps more modular, test-friendly, and easy to maintain. So again, if you go back to the previous section, looking at the design patterns, all about this decoupling, the separation of concerns, separating out those components, so that they were using those principles, and that was at the forefront when they were bringing in these new components. Okay, so the next point there, lifecycle, live data, room, view model, and data binding were all part of the initial architecture components release. And again, I'll look at those in a little bit more detail later on. But we're going to be looking at very regularly our live data, our view model, and data binding in later sections. So that's going to start cropping up, and that they are fundamental components within the MVVM. And again, I'll probably talk about that in a minute anyway. Okay, now so bundling Jetpack, there's a lot more to offer. So that's something you should be getting your head around as well, and becoming familiar with, is Android Jetpack. Okay, just to kind of show you their own graphic, what they'd have up on their own site, the different kind of components within the overall Jetpack. So to have it split into separate categories: architecture, UI, behavior, and foundation. And if you look at the section themselves, so within under the architecture umbrella, you can see here, look, there's our live data, there's our view model, we'll be working with that. There's also life cycles, there's data binding. So again, as I said, this section is very important going forward with the rest of the material that we're going to cover. It's all driven by this new kind of the architecture components. Okay. You can see there under foundation, look, Android KTX, Kotlin extension libraries. So we can probably look at that a little bit as well. In our UI, you might want to investigate some of that yourself. Different animations, transitions, that does kind of crop up under the navigation component, which we would have covered, and which also ties in there with fragments as well. We have our look at different layouts, all the rest of it. And then under behavior, if download manager, look, media and playback, permissions, we'll be looking at that. And we have a little bit on sharing, and again, kind of slice it there as well. So if you want to, you can go off and you can have a look at some of those other components within the overall Jetpack library. But as I say, we'll be focusing mostly within the architecture section, architecture category. Okay. So the official kind of blurb from Google, why use Android Jetpack? So they're saying follow best practices. So again, just ways to try and help the developer build good, robust apps that will enable, as I say, fewer crashes and less memory leaks. Memory leaks is a big one, and again, as we'll see now with the architecture components themselves tied with MVVM, it really kind of handles those issues and deals with those in a very nice manner. Okay. Another reason there, eliminate boilerplate code. Again, you rather than having to write all the stuff yourself, write all the code, you can bring in the dependencies and just go and use the components themselves. So it's more about understanding what the components can do for you and when to use them. And again, that's all part of Jetpack. And the last final one there, final from their kind of official site, reduce fragmentation, which is, again, because of the way Android has gone now at the moment, reduces complexity with libraries that work consistently across Android versions and devices. Because now Android is so pervasive on so many different types of devices, and there's so many different versions of Android still out there, that Jetpack tries to, as I said, reduce complexity and keep it very consistent, so that if you build for Android 10 and you've been building using Android Jetpack and using the Jetpack components, in theory, it should work seamlessly on previous versions of Android. Okay. And again, look, you can get a lot of it there on the developer on android.com/jetpack. Okay, so if we look now at the specific Android architecture components that Android have developed and are encouraging developers to use in building these complex Android apps. Okay, so according to Google, the Android architecture components are a collection of libraries that help you design robust, testable, and maintainable apps. These components help solve many of the problems that Android developers face on a project. So again, simple ones like screen rotations, sharing your data, your memory leaks, trying to cut down on crashes. It helps create a clean and easy. It helps create a clean and easy to maintain architecture such as MVVM, with the goal of taking advantage of all the capabilities of the Android framework and its structure. So as you can see, they're going to use basically the same terminology. So within the model view model, there's a view model component within these architecture components that would be used in exactly the same way. So even though MVVM is a design pattern, Google are directly adopting this for building Android apps and have developed specific components, these architecture components, to allow a developer to apply that MVVM pattern. Okay, and MVVM is what Google are recommending. And again, that's another reason where we're going to actually build it and apply it as well. Okay, so we'll take a brief look at those components. Okay, just break them down for you. Okay, so first one there, life cycles. So manages activity and fragment life cycles of our app. Survives, this is important, survives configuration changes, avoids memory leaks, and easily loads data into UI. A big problem in prior to these particular components, as I say, was something as simple as the user rotating the screen. What that caused your activity to shut down and restart again. And if you didn't have proper code in place to manage that kind of configuration change and that screen rotation and running through the life cycle, it could crash your app. You could lose, as I say, you could have memory leaks. There's data getting lost, and using the lifecycle component does away with all that. So you can actually keep track much more effectively and efficiently the life cycle within your app and how data is managed within that life cycle. Okay, next one there, live data. So this notifies views of any database with quote database changes. You can use live data to build data objects that notify views when the underlying database, now when we say database, any kind of your raw data, whatever you're linking into. So generally what we will do is we will use live data and certain types of live data to manage the objects that we want to store, and that then will tie in with the life cycle, so that we're not going to lose the data if there's different states within the life cycle. So if an activity restarts, whenever it's paused, if it resumes, our live data coupled with the view model, we'll be able to manage our data and cause kind of automatic updates to the view. This is a really nice feature as well, is that we can, the term is observe our data. Okay, so no matter where it changes within our app, we can ensure that that data is automatically updated. So we don't have to go and refresh, we don't have to manually check ourselves. This will be done automatically within and using these architecture components. Okay, and just following on to the next one there, the view model manages UI related data in a life cycle conscious way, stores UI related data that isn't destroyed on app rotation. So we will see a lot, and even if you do your own kind of little bit of research on MVVM and these architecture components, you will see a lot of usage of live data within the view model. So those two components together can ensure no memory leaks, can ensure automatic updates, can ensure data isn't destroyed, isn't lost. So again, makes for much more robust, much more scalable apps. okay, and easier to manage. Some of the next ones there, data binding, again we'll be looking at this as well, helps in declaratively binding UI elements in our layout to the data sources of the app. So we don't have to write code in our activity or in our controller, so to speak, to update content, update data in the layouts. We can, using XML, directly bind to the underlying data. So whenever the data changes, the view will automatically change as well. And this is that's a really nice feature and of this particular component. Other ones there, we have Room. Navigation. Room is an SQLite object mapping library. You may have come across it before. We won't be looking at it, but if you do want to have some kind of a database backend to your application, Room would be definitely a good solution for you. All right. Room also provides compile time checks of SQLite statements. So, and you can even use some of your SQLite, maybe if you're coming from be it Java or even a desktop app, which would have connected to a database, you can bring in those SQLite tables and the table data if you need to. Okay. Next one there, navigation, handles everything you need for in-app navigation in an Android app. We've looked at this in previous sections. The navigation component, really nice component for speeding up and managing, especially working with fragments within your application. Okay, so again, one to recommend. Last couple there, we have paging, which helps in gradually loading information on demand from a data source. You may be familiar with this if you've done any kind of web development. So again, we don't have to load up everything in one go. May take a long time, especially if you're downloading it from some cloud resource. So paging will give a much better experience to the end user. And then finally there, Work Manager, an API that makes it easy to schedule deferrable asynchronous tasks that are expected to run even if the app exits or the device restarts. So again, would tie in with any kind of cloud-based data. If you want to run something in the background, this Work Manager component will give you a lot of functions to that you just essentially use, as opposed to having to go off and write all your own kind of asynchronous code in the background. Okay. So just to wrap it up there, quick conclusion. All these libraries will help us write code that's cleaner, faster, more scalable and easier to maintain. But there are a lot of steps to using these components and implementing the recommended architecture. So the most important thing, right, is to try and create a mental model of what is going on and understand how the pieces fit together and how the data flows. So again, you're rather than just diving in and trying to use all these different components, you're much better off taking a step back, hopefully choosing the correct design pattern that you want to apply, and then look at what the architecture components can give you and look at what those different components do and will allow you to do, and then decide which components you kind of need to use. Now again, going back to what Google are recommending, is that they are saying to and recommending to use MVVM. So that's why you would definitely be working with live data, working with view model and data binding, and we will see all those now in our code walkthroughs and in later versions of Donation. Okay, so again, I think I have some references there for you as well. Yeah, similar set of references. Okay, so if you want to kind of have a look at those, you're more than welcome. So other than that, thanks for listening, and goodbye. Hello again, and welcome to the next topic in our overall kind of architecture section, which is MVVM, the MVVM pattern in Android. So we're going to look specifically at MVVM within Android, and how we can apply it. Okay. So the agenda, as I said, we'll do a quick recap, just to refresh our memories on what it is. We will look at the components in detail. Okay, so it's very important that you get a good grasp, a good understanding of what the components are and how they work together to allow you to then apply the MVVM pattern to your particular application, your particular project itself. And to try and explain that in a little bit more detail, a bit better, we look at a simple code example that you could then possibly apply elsewhere. Okay, and then we'll finish off with a summary, and I suppose in the final section then we'll actually just do a code walkthrough of how we've applied MVVM currently within donation, how we refactored the application. Okay, so just a quick recap. What is it again? Currently, industry standard recognized software architecture pattern that overcomes the drawbacks of the MVP and MVC design pattern. So again, we would have covered that in detail back in that first section. It suggests separating the data presentation logic, your views or your UI part, from the core business logic part of the application. And again, that was the big issue with MVC. You ended up having, as your apps got more complex, you ended up having very logic heavy activities, which were kind of your controllers, which were then tied to your views. So there was a lot of kind of blurring of the lines there. Okay, it has three major components: your model view, view model, and a fourth one, which is our binder, which is your data binding, and we look at that in detail again in this overall section. Okay, so just to recap on the kind of high level look at how it all hangs together. So there we have our model, our view. Again, no totally decoupled, no interaction whatsoever, which is big plus for the pattern. But also the view is decoupled from the view model. I won't say the controller as such, but just that component within the overall design pattern, which again is a plus for testing and scalability. Okay, so if we look at the components in detail, okay. So you will be familiar with some of this, but there's no harm in kind of just going over it again. Okay, so models are components that are responsible for handling the data for an app, right? They're independent. That's the key here. The key here, they're independent from the view objects and app components in your app. So they're unaffected by the app's lifecycle and the associated concerns. Again, not to go on about it, but that was the big issue with MVC, is that because there was a link between the model and the view, changes in the app's life cycle could have had a negative effect on your model component. Okay, but that's all done away with within MVC. Okay, now with the model and view model work together to get and save the data. So we'll see that a lot now in the example, and then in our own kind of code walkthrough as well. Okay, generally it's recommended to expose the data in your model, right, to the view model, okay, through observables, right? So that's going to be our live data in Android. So the view model component and live data component will work very closely together to achieve this goal of displaying, updating, managing data within your app. Okay, a little bit more about the specifics of our different components. So if we look at the view model itself, that was a bit about the model, how it interacts with the other components. We'll talk a little bit about the view model here, right? It's an object. A view model object provides the data for a specific UI component, such as a fragment or activity, and contains data handling business logic to communicate with the model. So again, a lot of the code that would have initially been in an activity should really be in the view model. And we look at some principles later on now as well of what kind of the do's and don'ts of trying to apply the pattern itself. Okay, but as an example there, the view model can call other components to load the data, and it can forward user requests to modify the data. Okay, so as I said, most of the business logic and will end up in your view model, and you can have more than one view model within an application. All right, so there's a kind of general rule of thumb: whatever the particular feature that you want to implement, it will generally have a view model to kind of manage it, to represent it. So within Android itself, when you go and build, for argument's sake, and use the wizard to build a nav drawer, depending on the features, it will have a corresponding activity fragment, right, or slash fragment, and a corresponding view model to work with that particular feature that you want that. So whether it's a simple list, whether it's an ad, an update, or whatever, it will automatically supply you a view model to accompany the corresponding fragment, okay? Which is a kind of nice feature within Android itself, okay? The view model doesn't know about UI components, so it isn't affected by configuration changes, such as recreating an activity when rotating the device. Again, one of those common problems that would have cropped up within the MVC has been done away with by applying the MVVM design pattern and using the architecture components. One of the obvious one here, the view model component, okay? A little bit more about the view. Okay, so in MVVM, the view is very lightweight because it has almost no logic in it. That's, again, going back to MVC, the majority of the logic would have ended up in the activity, which would have kind of controlled the view as well. Okay, so that's all been done away with. The view is mainly responsible for everything UI related. So you should, again, we would have come across this before, but just to no harm and kind of been explicit about it. Your menus, event listeners, showing dialogues, toasts, your snack bars, starting activities, switching between activities, whatever, okay? In Android, the view is usually an activity or a fragment. Its role is to display whatever it receives from the view model and forward input to it. And the final point there, the view observes, that's the important terminology there, the view observes the view model. So what we will end up seeing, and we see examples of it later on, is within our, be it an activity or be it a fragment, we will have very little logic. It will be just essentially triggering events, calling functions on a view model object or observing a view model object. And within the view model object, we're going to have our live data. So ultimately, within a view, which is observing a view model, which is managing the live data, when the data changes, our view will automatically be updated because we are observing it. This is all part of those architecture components, okay? Hopefully this will become a little bit more obvious and evident when we look at some examples later on, but just trying to give you an idea of how it all pieces together, okay? So some of the principles for our view model communication, okay? So again, the view should not have any logic in it. We've kind of mentioned this now on a couple of occasions. Not even a simple if condition, if, pardon the pun, if possible. So if you can at all, don't have any actual logic in there at all. All you should be doing is triggering events, calling functions on a view model instance, okay? All logic for the view should happen and does happen in the MVVM approach in the view model. Okay, so just looking at a simple example here, this possibly would be inside your view. There's my view.visibility. If, and again, look, a user dot is admin. So you're checking some other component, tying back to your model, possibly directly to your model. This user should really be maintained inside a view model instance, and then you trigger some function on the view model to go look at your user. Okay, so that's the kind of approach you probably should be taking. Okay. In response to events, the view should only notify the view model by calling a method, nothing more. The view should not pass any view related classes to a view model, so you shouldn't be passing around references. That's where the memory leaks kick in the first place. Okay, so it's all about just triggering functions. So in this example here, and we will see some of this in our own kind of code examples, we have this button which is on the view. We're setting a click listener. There we are just triggering, saying submit data on a view model. So whatever's going on inside that, it's in there we would be accessing possibly the raw data. Okay, and again, we will see later on how we can pass information around. That's all done through our data binding. Okay, so that's the binder element, which we'll cover now soon enough. Another one there, number 3. The view model uses live data as the primary means of communication or communicating with the view. Okay, the view only observes the data and is notified of any changes. So this is very close to the kind of code we'll be looking at, and you will see this quite a lot in both the examples we look at and in within donation itself. So here's our view model instance. We have some property of that, .admin accessibility. That would be our live data. And we can observe the live data through our observer element. Okay, so again, these are implicit elements that come with the view itself. So the view only observes the data, and then there's the view.visibility is assigned. So this would be the like the iterator, like going back to our data structure, if you can remember back to that, which kind of just standard Kotlin stuff. This will get at the view, the visibility property itself. So whatever admin access visibility in this example here, whatever value that would have, we are assigning directly to the my view reference, which is inside this view model, which we are monitoring, essentially observing within the view. Okay. Final one there. The view can call the view model whenever it needs something, and the view model can provide helper methods for the view if necessary. So again, it's kind of, we might have some kind of example like this. So this function, this is inside our view model, and it kind of returning an if condition based on, so if the view element is visible, right, or else view.gone. So that could be triggered within the view itself, just returns an integer value there. But this again would be just called from the view, and then the view can provide those helper methods if required. Okay. Now, just to talk a little bit about our MVVM components again, the binder. Okay, so the binder is some component that performs the actions described by the binding. They are important to the MVVM framework as they allow you to decouple the view from the view model and does the heavy lifting of handling the synchronization of state between the two. So it's like a middleman between your view model, which ultimately is managing your raw data, and the view itself, how you want to display it. So these binders allow for that kind of synchronization, that movement of data between the two. Okay. And that's what we're going to be using again. Specifically, we have a data binding library, which is part of the Jetpack overall kind of suite that we can use within our application. Okay, so just last point there, the binder does the following: interprets bindings defined in typically the UI, so that we can attach directly to properties of an object within the layout. We can pass in a reference to our data actually declaratively within the layout, which is very, very nice. Okay, it observes the view model for changes in state and updates the view, and it observes the view for changes in state and updates the view model. So we can manage the data both ways via the binder. So it's very like, if you've done any web work at all, it's very like that two-way data binding in the likes of Vue, in the likes of React and all the rest of it, so that you can if it's updated in one place, the changes are reflected in the other, and vice versa. Okay, so if we talk a little bit about data binding before we kind of look at our example, right? So the data binding library in Android is a support library that allows you to bind UI components, okay, in your layouts to data sources in your app using a declarative format rather than programmatically. So what we would have been familiar with something like this. So we could say we'd have our find view by ID. So what we're saying here is we want to bind to a particular text view. There's the reference, so it's called sample text, which is on the layout itself. That's the ID of what we're looking for, and then we're saying we're going to update the text property with the view model dot username. So whatever the username of the view model is, we want to update the text field of the sample underscore text view. Okay, now that's a couple of lines of code for a very simple assignment. Okay, so if you extrapolate that out, where you might have 5 or 6 individual text views that you want to populate, those start getting a bit unwieldy within your code base itself. Okay, so that's without using data binding. And again, you don't have to use data binding. You could quite safely use code like this, but the whole purpose behind Jetpack and these components is to make the developer's life easier. So if you do have the opportunity and you can use those components, then it's recommended that you do. Okay, so if we look at an example without it, okay, so the data, as I said, it's a support library. So with data binding, so if you notice here, this is directly inside the layout itself. So here's our text view, here's our text property, and again, note the @ and we're saying, so we're activating, this is a directive. Again, very similar to what, if you've done any web kind of coding at all, any with Vue or Angular, React, any of those. Here we are getting directly at the username property of the view model. And if you have it implemented correctly, you could actually change that in-house in the field itself, and it will update the view model. Okay, and again, so all this removes the need to call the code previously. So if you think about it, 5 or 6 fields in your layout, you can access and get at the text property directly, declaratively, like so, doing away with, if you use the previous example, 10, 12 lines of extra code just to get in and just to set and update a field on your layout. Okay. So if we look at an example, okay, so we'll take a small example here. We'll demonstrate how all the pieces fit together with a simple app using a person, and eventually update, change their details or their age on the click of a button. So the idea would be that we have a very simple app. It's working with a person object, which has 3 properties: first name, last name, and an age. And then simply clicking a button on your layout, on your view, will update the age of the person. Okay, so we initially start with the model. So we have a basic data class there of type person. And again, there's our 3 properties, 2 strings and an int, giving them some default values. So kind of nothing new there, hopefully. In terms of the dependencies that you'd have to bring in and the options you would have to turn on, right, will be as follows. So we can see here we have our Android X.lifecycle, and again, notice we're using the KTX dependency. So again, wherever possible, it's always recommended to use those. So to begin using your view model, your live data and data binding, you need to add in the required dependencies and just make sure that we're turning on the view binding and the data binding. There's a subtle difference. View binding only allows you to display them. The data binding is like your 2 ways back and forth features. Okay, so kind of just if you want the full effect of being able to update your UI layout and the view model through a data binding, you would need to have both of those turned on. Okay. So if we look at our first look at a kind of a view model of what it might look like, okay. So here we have our class person view model. Again, the terminology is generally, if we have a class called person, its view model is person view model of type view model. So we're hooking into that component, that architecture component. And the recommend, you don't have to do this, but the recommended approach is something like this. Okay, that you would declare your data privately first. So you can say private, so with val individual person is of mutable live data. So that basically means that we can change this person information. So this is just a single person instance. So you can see it there. There's the reference to the raw data, the data class. So we're wrapping it up in this mutable live data, which means we can observe that. So any changes will be automatically reflected back in the UI depending on what we want to do. Okay, so as well as having your private property, okay, called person, we offer a public observable person which can't be changed, which is of live data, right? But we can get at it. Okay, so we offer a get accessor method or function, right, which returns that person object. Okay, my colors are gone a bit mad there. So that's generally the approach to take. So that's what we're going to do. Okay, that we declare the mutable data private, and then we offer the public or the observable data as the live data. So again, that's read only, that live data. Okay, all just for making your app, your overall kind of design a little bit more robust. Okay, initially, when we load up that observer, we're going to call the load function, and all it does is assign or create a new instance of a person object. So the person dot value, and this is important, that any live data I suppose object will have a dot value property. So it's the dot value is the raw data. If we try to say person is assigned person, because person is of type mutable live data, you would get an error there of invalid type. They're not the same type. So it's the person dot value, the dot value property of your live data is equivalent to whatever type of data you're managing. So here we're managing a person, so the dot value property of our live data is a person object. So when we create a new and we start to observe a person view model, what we get is a new person created. Okay, so that's what just happened within that view model. So if we then inside our, be it an activity, be it a fragment, so in this instance here, it's actually, because it's a basic example, this will be inside a activity. So this is inside our on create. So the first thing we do, and we're kind of, there's a look just to be complete about it. Here we are, a throwback to our kind of view binding. So we're attaching to the layout, and this is what you're going to see quite a lot of in later examples, and even hopefully when you're building your own assignments and writing your own code, that this is how you will manage and apply the MVVM. So we first instantiate our person view model via the view model provider. So we can see it there. We say view model provider. We have to pass in a reference, that be it the activity or fragment. So in this case, it's an activity. Sorry, color's gone a bit mad again. So that retrieves an instance of our person view model, and then we observe that person view model, specifically the observable person. So this is our public read-only property that we have declared inside person view model. Okay, and there we are, dot observe. There we are passing in the implicit observer again, and all we do inside it is when our person data changes, which is, and this is the person object that's automatically passed in. It's like an iterator again, but go back to any kind of data structures work you would have done with lists. We're just calling a person here. So whenever the person changes, what we want to do is we want to call this function render, passing in that newly updated person data. So if we look at our function for render, all we do is on our layout, we set the first name, the last name, and the age properties to first name, last name, and then a text version age of the person itself that was passed in. Okay, so whenever person changes, that will trigger automatically a call to render, because we are observing the live data, and this last call here, execute pending bindings, just causes it to be executed immediately, so that we can we're just kind of forcing an automatic application and assignment of the person object to the elements on our layout. Okay, so any change to person anywhere in the app will trigger that call there. So you're always making sure and guaranteeing that your data is synchronized, which is quite useful. Very simple example: you have a list and an add. User jumps to a new activity, new fragment to add. the user then hits the back button, which would cause changes in the life cycle, so the activity will pause, come back. You don't have to have extra code in there to track all that. Because you're observing it, the data itself will automatically be updated. So if you've added it to the list will be updated accordingly. Okay. Now, if we bring in data binding, so if you kind of ask yourself there, but this kind of defeats the purpose of what we were talking about. So we can now kind of modify this with a little bit of data binding. Okay. So what we can also do is inside our layout. So again, you'll see some of this as well. Okay. Inside the layout, this is important. It's inside the layout tag. Okay. What we do is we bring in a data element. Okay, which references the person view model, and you give it a name. So here what we're saying is we're bringing in a new variable, new data variable, calling it person VM of the particular type. Okay, so that goes at the top of that layout tag. Okay, and how we use it is something like this. Inside a text view element, so here we're giving it, there's that same, do you remember the TV first name which was on the previous a couple of slides ago? Here we can update the text property with, again, the first name property of the observable person property within our person VM view model instance. So that was declared and was passed into basically the layout when it got inflated. But when the person object changes, it will automatically be updated here. So we don't actually need that render function at all. So because we are observing the person data and we have data binding turned on, any changes to our person object, person data, the live data within the person view model will be reflected in the layout. And just as an aside there, because we're dealing with integers, you would need to do a little conversion using the integer class like so, because age would be a number, so you want to convert it to a string to display it in the text property. Okay, just kind of little aside there, just something to be aware of. Okay. So introducing data binding. So this is, as I said, binding to data in the view. So that's before, that's after. So again, all we have to do is update the person view model. We don't have to set the fields individually. All we have to do is, because we are observing our data here, the minute the data changes, we update our view model instance with the person view model, and that will automatically update our layout. Okay, and again, notice because we're not passing in a person anymore, we're not. You could actually go back and you could remove that if necessary, and even remove all that and just call render, because all you're doing is working directly with the person VM instance, which is the element and the variable you have inserted into the layout through data binding. Okay. Just a little bit more about it there. If you want to bring in event handling, so we can update the model like so. So inside the class, we can have here, we're bringing in var age of type observable int. That's important to just note the observable int. So in this instance, we want to track and observe the age property. So instead of a basic int, if we declare it as an observable int, when age changes, that will trigger an event, so that we are as I said, keeping track. We are observing the age property, the whatever value that's going to be, and then that can be reflected then in the layout as displaying the data. Okay. So what we'd say something like this, we could in our activity, possibly in a fragment if necessary, we could bring in our main binding dot button holder. So we have this button holder button on our layout attaching the listener. When we trigger the older function on our view model, that will cause the age to be updated, which will then, because we're using data binding in our layout, will cause the age to be automatically updated and changed accordingly. Okay, so keeping it all synchronized. But again, because we have data binding available to us, we can actually implement that in our layout as well. So in what we can do is we can trigger an event using data binding. So this is again another just bit of syntax to be aware of. We can have in our button, in our on click, there we're using our @ notation again, but this is the syntax to trigger a function call on the person VM.holder. And remember, what is the person VM? Person VM is a view model instance that we have passed into the layout directly, which has within it a .holder function. So when we trigger that, when the user clicks on the button, declaratively we trigger the older function, which in turn updates the age, which is observable, which in turn updates the layout with the new age value. So again, no need for any of that event handler code. So you can, by using this data binding, you can drastically reduce your code base and a lot of the logic that you might be having to work with to trigger functions that are part of your view model instance. Okay. So to wrap it up, in the MVVM implementation, only a view, right, fragment or activity, should reference a view model. The view model should have no knowledge of the view and should not reference the application context from the view. You should leverage the Android view model class and to provide an instance of a view model in the view model using your view model provider. So that's how you basically bind to your view model within your activity within your fragment. You can't observe until you have a reference to it, until you've bound to and you provided an instance using that view model provider. Okay, and the last one there, wherever possible, keep the end-to-one relationship between your view and your view model. So multiple views can reference one view model, but if a view has to reference to two or more view models, it should be broken down into smaller views. Okay, so just again, all to do with trying to keep your application scalable, manageable, and trying to, I suppose, keep the logic as streamlined as possible within the view model. And again, this goes back to what I was talking about within Android Studio, that if you are building a Navigator app, for argument's sake, it will automatically supply you for the features that are available and the options that are available on the menu. It will give you a one-to-one in terms of the fragment and the corresponding view model just for that particular and allow you to bind and use data binding to bind to that particular layer. So it doesn't try to mix and match too much. Okay, so again, I think I have the same references for you there. Okay. Any questions, any issues, you can get me on Slack or over email. But hopefully when you're working through the lab and the code workthrough and the rest of the section, we'll hopefully make things a little bit more clearer for you. And practice makes perfect. When you start using this and you start working through the lab, hopefully it'll start making sense to you. But I do appreciate that it can be there is a bit of a learning curve to it, okay? Especially if you're not familiar with MVC or MVP, okay? But other than that, look, thanks for listening, and goodbye. Hello everyone, and welcome to the last part of this section, all about architecture and design. And this is our Donation X code walkthrough version 3. So we're just going to have a look at our kind of third version of Donation, where we bring in and apply the MVVM pattern and bring in our view model, our live data, and kind of look at how we can refactor the code from the developer's perspective. Again, the feature set from the user's point of view won't be that much different, but there will be quite a substantial change to the design of the app. And then we will use this design going forward for the rest of the versions of donation. Okay. So I'm going to break it down as follows, the agenda. So again, have a quick look at our project structure. We'll have a look at kind of the view model communication. Okay, and we'll use a couple of use cases to demonstrate that. We'll also look at a bit of data binding, and then, as I say, the relevant code extracts to try and explain and talk through and go into a little bit more detail about what you will be looking at in the lab while you're doing it. Okay. So if we look at the project structure, this is what we have at the moment. So again, it's auto-generated by Android Studio, right? And we factored it with existing code base. So what we've done a bit of chopping and changing, as they say. So we would have, in the lab, we would have got you to start with the nav drawer template, and then we will bring in the existing code that we have. Okay. So if you notice what we have over here in our overall donation X package, there's activities, we have the adapter. So again, we're going to look at that because that's important in terms of what we'll be using in some of the code we look at. We have our application object in the main package. We have our models, and then with the wizard we would have got this overall UI package. And as I would have mentioned in previous sections, previous videos, the way Android Studio does it, it tries to couple together the fragment, like your view, and then the view model element. So whatever the features that you might want to have in your overall application, this is what we're doing. So we have our separate kind of about screen. We're going to have a detail screen, so kind of for editing and eventually in looking at more detail about the donation that was made. There's kind of the original donate and then the report. So we will focus on the detail and the report fragments, the report view model, donation detail and report view models, just to try and demonstrate the inner workings of these new components that we're bringing in into our overall application. Okay. So as I said, we start with reports. So we look at MVVM in report. So again, the view and view model communication and how we go about displaying our donations. Okay. So again, a quick recap. I just hide myself there now, present. Okay. So we want to add our donations. We can click on the add button there. We get what we want. We have our hamburger menu up top to navigate between the different options, and then we have our, as I said, that's the kind of the main donate screen. We have our report screen, is pretty basic at the moment, just a placeholder for images and just displaying an amount and a payment type. Okay, so to delve a little bit deeper into how that's now displayed and how we communicate between our data and our views, right, with and after applying the MVVM is as follows. Okay, so to begin with, we have something along these lines. We have our report view model. So as I say, extending from view model, taking the recommended approach where we have the raw data, so to speak, which accesses our donation model. Or creates a list, a donation model list, but it's mutable. So we have mutable live data, okay? And then we expose the public observable donations list with a get accessor, which will just return that donations list. Okay, so this is how we'll access it through, and we'll observe donations, the observable donations list object. But look, again, you don't have to, if you want to cut down on your code, you could actually make that public, but again, you're kind of going slightly against the recommended approach. And very similar to the example that we had, when we initialize our report view model and we get an instance of one, we will call this load function initially, hence inside our init block. And what that does is that assigns to the value property of our mutable data donations list, which is this one up here, donations lists, right? Our donation manager.findAuto. So again, this is going back to our kind of interface, so to speak, and our find all will retrieve a list of our donations. Okay. So if we have a look inside the on create view, and again this is slightly different because this is inside a fragment as opposed to an activity. So we're not working with on create, we're actually working with the on create view. Okay, hang on, just changing my color there again. Okay, so again, just there's one point to note, it's inside our on create view, and again the view binding is a little bit different as well. Okay, so just make a note of that. We would have touched on this back in previous sections, but again, just be aware that it's a little bit different, and that the approach taken when implementing view binding in fragments. Okay, so here we are. This one is just setting up the linear layout manager. Here's the important bits for us. Here we are getting an instance of our report view model via the view model provider. Okay, and here we are now, and because this is inside a fragment, we have to pass in the view lifecycle owner implicit object there. In previous examples, because we were inside an activity, we just passed into this reference because obviously the activity was part of the lifecycle. But because a fragment lives inside an activity, the correct reference is our view lifecycle owner. So that's getting passed in there. There's our observer. And similar to the example, what we do is we observe the public live data, our observable donations list, and when our donation changes, we call render on that data, that list of donations that has now changed, and we pass it to our render function. We'll look at that now in a minute, what that does. But this is what we are observing inside the report fragment. Okay. We also have a on-click listener attached to the floating action button. So if the user clicks on the button, what we do is we create an action there, tied it to our navigation component. So again, all this is looked after for us. We don't have to create a new fragment transaction. We don't have to name it individually. We don't have to have the call the dot commit to cause the transaction to happen. It's all done through the navigation component and a report fragment directions dot action report fragment to donate fragment. This is what we would have got by default. You could and can change this in the navigation component itself if you go to that within Android Studio itself. I'm just taking what was supplied to us, but as I said, you can change it if you need to. And then we use our find nav controller to navigate and jump off to that particular fragment. So these couple of lines of code here will ensure that if the user clicks on the floating action button to add a new donation, we are automatically via the navigation component taken to the donate fragment. And again, we're just using the default function itself. It was when we added the fragments within the navigation component itself. It gave us that method itself, which will automatically create a transaction, commit it, and if necessary, pass any parameters. We're not here now at the minute, but we will later on. We will see that, and jump off to that other fragment that we need, which is our donate fragment. Okay. The render itself to display the data is as follows. So here we are inside render. So we're passing in this donations list. So remember, this is the live data value that was updated because some change has been made to the list. Okay, or whatever the existing list happens to be. So we create our adapter, passing in that list, and we just have some extra checks going on there. If it's empty, just display the visibility that just the recycler view will either display it or not, and display a donations not found. But again, not too difficult to kind of grasp. A simple displaying and assigning of our donation adapter, where we've passed in our donations list, assigning it to our through the view binding, the fragment, the recycler view adapter property within the layout itself. Okay. If we look at the adapter, or internally inside the adapter itself, a little bit extra going on. So inside the bind, okay, so what we're now, because we're using our view binding here, right, we're assigning, and again, this is why this is great, because we're not actually getting in at the individual properties anymore. We are assigning, and we'll look at that now in the next few slides, we are updating the donation data element that we have inserted into the layout with the individual donation that has been passed to our main holder class and internally inside the bind function to attach our data from the donation, the raw data donation, and display them in the layout via data binding. Okay. We also do the same with the image, just setting it default. We will actually kind of refer back to this again. We'll be changing this, and we actually assign a click listener on our interface so that when we click on our on that row, we can actually go into our kind of edit. Okay, and that's why the donation. But we're kind of focusing on this is the kind of the more relevant line of code at the moment. So we've done away with the individual assignment, getting at the data. We're now using our data binding to update declaratively, as we'll see it in the layout next, our donation object. So there's one assignment, the whole donation been assigned to the donation that we are accessing in the layout. So in the layout itself, something like this. So again, inside your layout tag, you have your data tag. We're calling it donation. So again, just make sure it matches. That donation maps back to the binding.donation. Specifying the correct type. It's our donation model. And then inside the individual layouts themselves, we get something like this. There's our payment amount. Again, hasn't changed from the first version of donation. What has changed now is this here. Here we are, as we saw in previous examples as well in the last section, getting at the donation dot amount property, converting it to a string using our integer class, and assigning it then in the text field, or text property, should I say. And we do the same with the other text view as well. So anytime there's any changes made, that will be automatically updated for us. Okay. In terms of the detail, so again, data binding and displaying a donation. So this is where the data binding really comes into its own in terms of looking at details and ultimately, I guess, down the line, our edit properties. Okay. So again, actually, sorry, come back to there now again. Or just hide myself, you can see that there's our floating action button. So what we're looking at now is when we want to click on an individual row and go off and look at the particular detail of a donation. So okay, so we get something like this. Okay, and notice again, just because this is not a root element, the detail, we don't have the hamburger menu. We have our navigate back to it, the kind of the parent screen, I guess. Okay. So how that works as follows. So here's our view model. We'll always kind of start with the view models. So our donation detail view model again keeps track of an individual donation. Okay, so there's our mutable live data. Here we are exposing the public read-only observable donation, and we have one function called get donation that will take an ID and update the donation value, which is again is our mutable data that we're keeping track of, observing, with our call to our interface, our .find by ID, passing in the ID of the donation that we want to get. Okay, so again, quite small, not much going on, just one function there, get. We may come back to these and we may revisit these in later versions, but for the moment, all we want to do is get at the donation to display. Okay, so then inside our donation detail, so again, it's inside our on create view again. Here we are binding, using our view binding. Here we are getting a reference, an instance of our detail view model, and here we are observing the individual donation. And again, all we need is a single render. We don't need to pass in any parameters in this case. And what we have here is, here we are setting the text initially to a message, setting the upvotes to 0, because we weren't working with those properties just yet. But here we are, this is the relevant line of code for the moment. Here we are assigning our detail view model to the donation VM, as I'm referring to it, that we would have passed into and referencing declaratively inside the layer. So whenever there are any changes inside our detail view model, because we are observing the live data, the observable donation, which is an individual donation element, when that changes, we simply trigger this call here, which in turn we use our data binding to assign that now up-to-date synchronized detail view model to the donation VM that we're referring to it in at the layout. So very similar to the previous example. If we have a look at our layout here, here we are referring to it again, the data tag inside our donation VM, and there it is. We're just accessing that it's the donation detail view model that we're working with this time. Okay, so that allows us obviously to assign one to the other, and then inside the layout itself we can do something like this. So inside the edit text, so again there it is, like there's our edit amount, there's our conversion again, just getting at the within the donation VM the observable donation and its amount field. And I think actually that's it for that little bit there, but I suppose it's there's not a huge amount to it. All it is, it's all the declarative code here. Okay, so that will tie back directly to the amount of the observable donation element that's inside your inside the donation VM. Just another way of accessing it. You may not have seen that before, but it's just another approach. Okay, so obviously if you're working through the lab, there's a lot more in it. We would go through in detail all the properties and all the changes that you need to make. But this, I suppose the important point to note with this is, because we're using our data binding here, we can actually apply two-way data binding, like as I would have mentioned in other sections, what you would see in the web world. So even though this is only read-only at the moment, with very little changes, we would be able to implement our edit features in later versions. Okay, so we will kind of revisit this again when we get to the adding in that kind of edit and delete features and a few other features as well as the versions go by. Okay, so again, just a quick summary there. We looked at the project structure, our view model communication, the data binding we're just focusing on there, and again, all done declaratively, all done through the layout and in the corresponding code extracts. Okay, so if you've any questions or any issues with that, or any issues with the lab as you're working through it as well, you can get me on Slack, you can get me over email, but